Okay, so calculating the volume word problem. So for the first ones, you are given a cylindrical water storage tank. Radius is 1 meter, height is 5. With these type of volume surface area question, draw a quick little diagram. It will take you 10 seconds, but it makes the math easier. So radius is that, height is that. So using the, since you're what is this shape? Cylinder, right? So volume of a cylinder, you have the formula sheet, it's that. Plug in the numbers, you have 15.7 meter cube. Remember, volume is meter cube. What would happen if the height of the container was doubled and the radius was half? That means now the radius instead of 1 is 0.5. The height instead of 5 is now 10. So sub it in and you'll see that volume is halved. Okay, it's halved because your radius is halved. It makes when your radius will make a bigger difference than your height because it's squared. Okay, assume the tank can only be filled with 90% of its volume. That means you times it by 0.90. It means 14.13 meter cube. Now, what do we usually measure water? What unit do we usually measure water? Liters, right? So meter cube is more for like air, space, that type. So that's why here I converted to liters, and the conversion between them is 1 meter cube is 1,000 liters. On the test, if I expect you to convert something like this, again, metric, imperial, I will give you the conversion. Yeah. So like if on the test, if this was on the test, I will say express final answer in liters. Yeah.
Isn't it only 14,130?
Did I give it,
You move it 3 times.
did I? Oh yeah, I did. Oops. Yeah. Thank you. 3 zeros, so I should move it 3 over only. Yeah. Okay. So Bella, here you go. I expressed it in liters, just for you. Hey, number 2. Hamden wants ice cream. Who doesn't? Okay, so the first one is a sugar cone with these dimensions. So am I doing volume or surface area? How do you know? It says volume? Oh, if I didn't say that, like if I just said I want the most ice cream. Yeah, how much can fit in the cone, right? That's right. So that's how you know we're talking about volume. So volume of a cone, pi r square h divided by 3. Okay. So 3.14 times radius. What's my radius here? 1, because my diameter is 2. That means radius is just 1. And so on the calculator, you're going to do 3.14 times 1 times 1 times 5, and then divided by 3. And you get 5.23, or just 5.2 is fine. 1 decimal place. So 5.2, what's my unit? Is that how we say it? Inches cube? How do we usually say this? Cubic inch. Yeah. Okay, but it's just FYI. I'm not gonna test you on how do you read it on the test, but we for these we call it cubic inch. Yeah. And then this one, notice right here, 1.3, but I drew it wider than this. Why is it? This one is 2, but this one is 1.3. Why is this waffle cone wider? Yeah, this sugar cone is in diameter. This waffle cone is in radius. So if you were to compare apple to apple, this is actually 2.6 diameter. That's why this is wider. So volume equals same formula. So 3.14 times 1.3, because it's already radius, and then times 4.2. Don't forget to divide by 3 because the formula says so. So 3.14 times 1.3 times 1.3 times 4.2 divided by 3, 7.4 cubic inch. Okay, so which one does he get more ice cream? Waffle cone, a lot more. Okay, and that's why they're more expensive. And it tastes better. Who likes waffle cone more? Sugar cone. Cup. Alright. I like waffle cones. Okay. This one, a cubic cardboard box has a volume of. What's my mistake right here? Yeah, it's volume. Talk about units. Have to mark off. Okay. I know there's another one. Yeah. Well, obviously I didn't type this up. I stole it from the internet. So, how can you determine the dimension of the cube? Okay. So, what can you say about a cube? All sides are equal. Yeah. So all the sides are. Whoops. Right. All the sides are. Do you need to go to the office? You can go to the office to get a band-aid. All right. So, what's the volume formula for a cube? It's cube. Yeah, cube. Okay. So for volume, it's 10. So if I want to solve for s by itself, like so, let's say if it's s squared, what's the opposite of square? Square root. So if it's cube, what's the opposite of cube? Cube root. Right. Exactly. Yeah. So on your calculator, it can actually do that for you, so that you don't need to do that. So you do on this calculator, you would do 3 because I want cube root, and then this button. So on your calculator, you should also have this, the square root button, and a something root button. Oh yeah, some calculators have already the cube root button. Yeah. So, no, this one doesn't. This one does? Where? Where are you pointing? Where are you pointing? Oh, well, why would they put the square root, the nth root, but then the cube root all the way down here? It just doesn't make sense. Okay, but anyway, so let's say you want to do the 100th root, you would do the same like this, and then that would say you want the 100th root of a number. So cube root of 10, you type it in like this, and you get 2.15. Okay. So 2.15 centimeters. Okay. In other words, you're saying that the length of each of your length, your width, your height is all just 2.15. So see, 2.15 times 2.15 times 2.15, you get 10. Yeah, we have to convert it. Oh. Who made this sheet? Yes, so this is it meters because this was meter cube. So to convert it to centimeter, you need to know the conversion of this. Times or divide? Times by 100. Good. When you times it by 100, 215 centimeters. Okay. Good. See, you guys read the question carefully. I didn't. Okay, Margaret, she bought new shoes and placed them in a shoebox that is 33 centimeters long, 19 centimeters wide, and 0.1 meters high. Calculate the volume and surface area. So this is her shoebox. Okay, you can already tell. What's the trick right here? So 33 centimeters, 19 centimeters, and what's my height? Meters. So convert that to centimeters. 0.1 meter equals how many centimeters? What do I do? Times it by 100. So you get 10. So height is 10 centimeters. Okay. Remember when you do volume surface area, you have to have the same dimensions. So, same unit. Same unit. Length times width times height for volume. So 33 times 19 times 10. 33 times 19 times 10. What's my unit? Centimeters cube. Good job. All right. Surface area. Length times width. Length times height. Width times height. All right. See all these formulas. Even if I don't give you the formula sheet, I think you guys can memorize it. You could. All right. So just to keep myself clear of what I'm subbing in, I usually like to write the letter beside it so that I don't sub in the wrong thing. So length is 33 times 19 plus 33 times 10 plus 19 times 10. Okay, do it all in your calculator. Remember bed mass if you are to do it separately. Plus 33 times 10 plus 19 times 10. Okay, 2294, is that what you guys got? Okay, and what's my unit? Centimeter square, because area. Okay. Number 5, April bought a dog crate for her new puppy. The crate has a volume of 70,000 cubic centimeters. It has a width of 40 and another width. So length, yes, it is a typo, of 50. Determine the height of the crate. Okay. So this is it a cube? How do you know? Yeah. Okay, because they already told you it's 40 and 50, so you know it's not a cube. So let's say this is 50, this is 40, and you're trying to find a height when volume is 70,000. Okay, so volume of what is what's the what is the name of this? Rectangular prism. Yeah, so if you look on your formula sheet, volume of rectangular prism, length times width times height, you know the volume, 70,000. And then the length is 50, width is 40, and then the height. Alright. So how do I solve for? So actually, let me write one more step. Okay, so 50 times 40, 2,000 each. So what do I do with that 2,000 now? Divide it. Good. So height equals 70,000 divided by 2,000, 35. What's my unit? Centimeters, because it's a height. Height is just centimeters. Okay, last one. The Great Pyramid has a square base measuring 230. Oh, pyramid. Okay. I know some people mix up the difference between pyramid and prism. So remember, pyramid, you have a pointy top. Okay. So the bottom is a square base, and it's 230 meters. It has a height of 147 meters. Determine the surface area. Okay, so surface area of a pyramid. If you look on your formula sheet, this one I forgot. Surface area of, you good? Okay. Surface area of a square base pyramid. SA equals B squared plus 2BS. Okay. Square base pyramid, surface area. That's the formula. Mohini, you're gonna help me with that since you are so attentive. Okay. What's B? Good. Okay, times 2 plus 2 times 230 again times S. What is S? That's right. It's not 147. 147 is my height. All right. I don't want the height. I want the slanted height. So whenever you don't have the a missing side, what are you doing? Pythagorean theorem. So by now you should know it's that. So slanted height is the one that we add. So this is 147. What's the bottom of this right angle triangle? Yeah, divide 230 by 2, so 115. All right. Are you going to see this question on the test tomorrow? For sure. For sure. All right. Where I give you the height, you have to find the slanted height, or I give you the slanted height, you have to find the height. So, like 100% sure you'll be asked something like that. So, whenever you're looking for slanted height, you're doing the adding one. And whenever you're looking for height, you're doing the subtraction one.
Wait, what's the shorter word on the test?
Some. Depends on the question. So 115 square plus 147 square. So C is the square root of that. 115 times 115 plus 147 times 147. 34834. Square root that. 186.6. Okay, so now I have S, so I plug it in, 186.6. And so my surface area. Say that again.
138,754.4.
We can just round it to the nearest. Okay. I didn't say it here, but I'll make sure I specify it on the test. What's my unit?
Meter squared.
Square area.
Isn't this you said this is calculating volume or volume?
Oh, because I want you guys to have to practice. See, it was determine the volume, but I'm like, no, too easy. And I changed it. All right. So that was yesterday's homework. We took 17 minutes to take up the homework because you guys didn't all do it. So we needed to take the extra 17 minutes. Okay, so now the review. I want to go over at least the first page with you guys, and then I'll let you guys do the rest. You guys should be able to do the rest on your own. I just wanted to make sure we go over this. Sarah has 20 meters of garden edging. What are the dimensions of the rectangular prism with the greatest area that she can enclose? Okay. So she has 20 meters of edging. So in other words, your given perimeter is 20 meters. Okay. Can I get some examples of dimensions? So let's say I have this. What's the dimension of this rectangle? So, for example, for this one, what's my length? What's my width if my perimeter is 20? Sorry? 5. Okay, good. So I can have a square, 5 and 5. Right? 5 plus 5 plus 5 plus 5, that gives me 20. What's another option? Yeah? 2. So, yeah, start with that. 2. I can have 2, 2. And then what would these two sides be? Yeah, 8 and 8. Okay, give me one more. Okay, so Dikshan wants to be special and use decimals. Okay, yeah. Whoops. Yeah, so yeah, we could use decimal. So 2.5, 2.5, 7.5, 7.5. When you add up all these, you get that 20 meters. But I want the greatest area. So for this one, what's my area here? 8 times 2? 16 meters square. What about this one? 7.5 times 2.5. My area is 18.75 meters square. What about this one? 25 meters square. All right. So which one has the biggest area? The 5 by 5. More importantly, what type of shape is it? Square.
Teacher, may I go
Sure. So remember, whenever it asks for greatest area, it's the shape of a square. In a 3D shape, greatest volume is the shape of a cube. So for area, your greatest area is when the shape is a square. If we're talking about volume, then the shape is a cube. It's always. So on a test, instead of having to draw like a whole bunch of different diagrams, you can just make it like a 10-second question because you know it's going to be a square. Possibly. Okay, so I hope you guys caught that hint. All right, calculate the area and perimeter of the figure. Watch the units. Okay. So what do I need to change here? Yeah. So millimeter to centimeter, what do I do? Divide by 10. So this is 6. All right. So conversions. Okay. So calculate the area. Okay. Well, I want the area of the rectangle plus the area of the two triangles. Or I could do the overall area and then take away that triangle. Which one do you guys want? This one? Okay, sure. Okay, so area of the rectangle is just simply 6 times 9, length times width. So 6 times 9. This triangle right here. What's the base? What's the height? What's the base? What's the height of this triangle? Yeah. So base is 3, height is 2. Base times height divided by 2. Don't forget the divide by 2 part. Base times height divided by 2. That's the area of one triangle. I have 2 triangles. That's why I times it by 2. 6 times 4. 6 times 9, 54. This. What does this symbolize to? 6. Right. 3 times 2 is 6. 6 divided by 2 is 3. 3 times 2 is 6 again. All right, so therefore my area of this composite figure, 60 what? Square. Okay. Perimeter. Now I need to find perimeter. How many sides do I see here? 5 sides. Yeah. So I know this is 6. I know this is 11. I know this is 11. I need to find this side right here. How do I find that side? Pythagorean theorem. See, it's I feel like I've said it for like the million times. Whenever you're not given a length, Pythagorean theorem. Okay, so this is 2. This is 3. I need to find out what that is. So I'm adding. So c squared equals 2 squared plus 3 squared. So c squared equals 4 plus 9. So c equals square root 13. So c is 3.6. All right. So now I can do my perimeter. Annie told me I'm adding 5 sides up. So I need to make sure I'm doing that. So this whole length, 11 plus 6 plus 11 plus 3.6 plus 3.6. And so my perimeter, 11 plus 6 plus 11 plus 3.6 plus 3.6, 35.2. And my units? Think again. Perimeter is the length. Just centimeters. Okay. Okay, so far so good? Good. All right. So I think this part, composite figure, area, perimeter of composite figure, you guys did it for the last 2 years. You did it in grade 7, grade 8, so that's nothing new. It's just a recap. This is the grade 9 stuff. Surface area. I know. Did you guys ever do surface area in grade 8? Oh, you did? Oh, some people did. Good. You have the experience. Okay, so surface area of a hexagon base shown. Okay, so this one is tricky. This is a tricky question. Surface area of a hexagon prism. Looking at our formula sheet, do we have a formula for it? No. All right. If it does, you'll be looking at a 10-page formula sheet because there'll be pentagon shape, hexagon shape, octagon shape, all those, right? So, but surface area means when you unfold it, let me draw the net. Yeah, that's right. You have triangles. It's okay. There. Okay. Eek. Okay. What happened to this one? There. Okay, so these are called nets. Okay, when you unfold it out, it's called a net. So these triangles, I can find the area of these triangles, add it up, that will give me the surface area of the sides. And then find the area of the hexagon, and that will give me the area of the bottom. So then when I add it all up, that's the surface area of the whole shape. All right. So these right here are just triangles. We know the formula for area of a triangle. All right. So looking at this diagram right here, how long is this part? 9.6. Good. Okay. That is S, which is my slanted height of this triangle. Do I know that? No. And when I don't know, yeah. Thank you. Yes. See, Sophia knows what I'm talking about. Whenever you're not given something, Pythagorean theorem. So I need to figure out this right here. Slanted height, I'm doing the adding one. So in this case, looking at this big diagram right here, I'm doing the r squared plus h squared. So 10 squared plus 12.5 squared. So 100 plus 12.5 times 12.5. So S equals square root, 256.25. So square root that, I get 16. So there we go. This right here, what we just found is that the height of this triangle is 16. Oh, because that's already the radius.
But like it's like the half of the
Yeah, so no, the usually like in the other base that I give you, it's in this case it would have been like the whole length. So I already halved it for you here. So this triangle right here is like a mid-air triangle.
But like the triangle, like the side triangles that you're calculating. Like what is the base?
Oh, so you're thinking about this rather than this. So this right here, this this 9.6 is just telling you that the base of this. So if I were to use the net to do the Pythagorean theorem, I would have that, but then I would have to be given this length to figure out that. So in this case, that's why I don't need to half it, because I'm already showing the half. I gave you the R, which is 10 right here. Okay, so how do I calculate the area of this? Base times height divided by 2. So base is 9.6, height is 16, divided by 2. 9.6 times 16 divided by 2, I get 76.8. What am I going to do with this 76.8? By 6. That's right, because I have 6 of them. I'm going to times this by 6. So then I get the area of all my triangles, 460.8 centimeter square. Okay, so that's all 6 of these. Okay, and then this part right here. So we don't know the formula for area of a hexagon. Okay, so we have to use our imagination and break it up into shapes that we know. Okay, what? Rectangle and yeah, good job. This would be a little easier than like the rectangle. So it's actually 6 triangles. Yeah, but then you don't know the formula for that either. Okay, so for this one triangle right here, okay, again I know the base is 9.6, and what's this length right here? 10. Yeah, because that is like this part right here. That's that. Yeah. Okay, so that is 10. And so now with this part, I can do the area of this triangle as well. Base times height divided by 2. So 9.6 times 10 divided by 2. 9.6 times 10 divided by 2. 48. And what am I doing with that 48? Times it by 6. 1, 2, 3, 4, 5, 6. Is it always 6? Why am I timesing 6? Because it's what's the overall shape? Hexagon. So hexagon is 6 sides. Okay. So if it's an octagon, what would I multiply it by? 8. Yeah. What's the 10-sided shape called? Huh? I think tetragon. I don't remember. Okay. What about the pentagon? 5. Yeah. Okay. So I have the area of the hexagon. I have the area of the 6 triangles. So my last step, what am I doing with the last step? Add them up. So total surface area of this hexagon-based pyramid is 748.8 centimeters square. Okay, so I know this may be a little confusing. So on the test tomorrow, I won't ask you guys to like solve a question like this, but I might ask you for the steps. Okay, steps. So how would you, like if you were to calculate it? What are your 3 steps, for example? So can you tell me what was your first step right here? Okay. So first step, draw the net. What were you finding? The slanted height. Yeah, S stands for slanted height. So the slanted height. That was your second step. Third step, area of the triangle, and then times it by 6 because it's a hexagon. And then? You
divide the hexagon.
Right, good. Divide that hexagon into 6 triangles and then find the area of that. Yeah, and then add it together. Okay. So that's so. If I were to change up the question and say it's a pentagon, it's the same 5 steps. Okay, but you would just have to say times it by 5, times it by 5, divide up that pentagon into 5 parts, 5 triangles. Okay. So, in terms of the actual calculation, I won't ask you guys to do it, but I will ask you to say your steps. Okay? Because that to me, it's enough to tell me that you understand the question. Okay, so for the rest of the class, I want you guys to try the rest of this review package right here. Answers are posted. So when you try these questions tonight to review, to study for your math, since you don't have any more other subject homework to do, click on here, geometry review answers. Yes, the one that says answers have answers. Whoa. Okay. And so you see here, okay, it has all the steps, everything. Okay. So try it. Make sure you don't. This is a good review. Okay. If you can do all of these on the review, you should be good for the test tomorrow. Okay.